Hey everybody, today I just want to do kind of an intro to instrument drivers in LabVIEW. So if you've never used instrument drivers before, basically these are ways that you can have pre-configured VIs that handle communications to instruments. So you can kind of just drag and drop them in and use them. So these are going to show up if you open your functions palette under instrument IO and instrument drivers. So here you can see I've got some already installed on my local machine. I can add more as I want to, etc. And then from there, I can basically just go and, here's my initialize, here's my close. Maybe I want to, set the speed in between there, right? And yep, that's pretty much it. So now I've got my instrument drivers set up. I didn't have to write any code. I didn't have to go read any manuals to try to understand the communication protocols and whatnot. So kind of just drag and drop. The really cool thing about instrument drivers is the majority of these are already written for you and you don't have to write them. So almost all of these on this page were written by other people, not by me. So I can basically just, install the drivers for a certain device, and they've gone ahead and mapped series of different commands, of different features, of different devices that are unique to each device. So really, really cool. If you're working with benchtop multimeters, with power supplies, with oscilloscopes, with function generators, electronic loads, a lot of those common benchtop instruments, they are almost all available with ready-to-go drivers. So there are very few devices that I've found in that kind of category that do not have ready-to-go drivers that I can just install and I'm talking to it right away, which is really cool. NI does have they call it their instrument driver network, or IDNet. So you can go on the internet and you can actually find these. So I can go see, here's these different devices. I can also search here, and I can basically find the device I want. So let's just look at this one, for example. So I found, these are the drivers available for this model. I'm programming this in LabVIEW, so I want to go to this driver page. And basically here I can see, who the manufacturer is, what interfaces this driver supports. So whether I'm talking to it over USB, Ethernet, GPIB, LXI, or serial, this will handle all of those, which is really cool. I can see when it was released, etc. I can see if it was NI certified, which basically means that NI has gone through and tested it and says, yeah, this is a good driver. And NI supported means if there's any issues, hey, you can reach out to NI. So really cool. And then down here, I can also see which versions of LabVIEW I can download this for, and the minimum Visa version. So whatever version you're programming in, just get the latest one that supports that, and you're off to the races. You also get a nice little list that says, hey, we've tested this driver on these different models. So in theory it should support all of these, but they've only actually tested it on these two. So basically letting you know, hey, across families of devices, right? This probably should work without any issues, but we haven't necessarily tested it across every possible, member of that device family. And then also from LabVIEW, if we go to Help and click Find Instrument Drivers, we can also connect to IDNet from here, which is really cool. So this pops up, and I can basically see here which drivers I already have installed. I can also do a scan for instruments, and it will try to detect connected instruments and see if it can find drivers for that instrument, which is really, really cool. I also can just go here and I can search by manufacturer. So let's go to Yokogawa. I can add additional keywords, but let's just search all Yokogawa. So this will take just a second. It's going to search the instrument driver network, and it's going to find all the instrument drivers by Yokogawa, which is really cool. It's still loading here, but you can see basically I have a list that breaks down these devices and lets me know whether they're NI certified or not. I can select a driver, and it's going to take just a sec, but this data over here will basically populate and say, what models does this support, what interfaces, basically all of that same information that we were looking at on the company website, if it's available, that is. So yeah, let's go to this one, and take just a second. And yeah, basically I can look for across all sorts of different devices and just find code that I can basically just plug and play and use in my projects. So yeah, Watlow, for example, makes a lot of different temperature controllers. The F4 I've worked with quite a bit, as I have the PD. So this will take just a sec to load, and then I can go basically look at these drivers. I can see, what the ratings are on them, etc. So really easy way to just find drivers. And then when I find the one that I want, I can just click install down here and it will install it to my machine, and then it will show up in my palettes. It's literally that easy. So let's close out of the little ID net. I also wanted to show how you can create your own LabVIEW instrument drivers. And there's a nice little wizard that kind of helps you do it. So if I go to Tools and go to Instrumentation, I can do this Find Instrument Drivers, which is basically going to pull up that window we were looking at. There's also this Visit Instrument Driver Network, which will take you to the website we were at. But I also can go to Create Instrument Driver Project. And it's basically going to pop up this little wizard where I can say, hey, I want to create a driver from a template, or I want to create a new driver copying an existing driver. So let's do from a template. And then I can specify the source of that template. So if I'm working with like a power supply or something like that, right, there's a whole bunch of common functions you're going to use with a power supply. So you're going to set your voltage, you can set your current, you can set your over voltage limit, your over current limit, you can set like turning your output on or off. There's a whole bunch of common functions. Same goes for like digital multimeters, oscilloscopes, etc. So I can basically select one of those, and it's going to give me a predefined set of commands that I just need to go fill in for each device, using the specific commands of that device. Also, what I do a lot is, because a lot of times these types of devices I find already have instrument drivers for them. People have already done that, whether that be NI, whether that be the device manufacturer. A lot of the devices I'm talking to don't fit into any of these categories, so I'll be usually looking at this general purpose, either message-based, which is like, hey, send a command, get a response back, or register-based. And this is more like your Modbus communications or like a PXI register mapping, where you're reading data in a specific location. So typically you're going to be message-based. I can specify the name of my driver. So let's just call this Canon Controls Demo. And you can include a description for your driver here. And that will be automatically updated in your project. I can set basically the banner for this. So yeah, let's just drop, this down here. Yeah, not the best, but just trying to demo. And that's going to automatically be applied to all of the VIs. It's going to show me where it's going to save it. And then I can just click finish. And this is going to take just a sec. It's basically going to create a whole project for me with a library that wraps my class. So you can see I've created this Canon Controls Demo LVlib. And in there, it's created, first of all, a readme.html. It also has a whole bunch of functions. So it starts off with like an initialize function. And it has basically a template of how you're going to start communications with most devices. There's notes here to let you know what stuff you might need to edit and, kind of dial in. For example, here it does an IDN query, and it's searching for instrument ID response. So you'll need to update this to actually include the response your instrument would give. And you may even just need to like delete sections of code, right? Because maybe this device doesn't support an IDE query or something like that. So it gives you notes on what you might need to edit. Some of these VIs, there's really not much to edit, right? We're just closing the device out. So And then it also creates action, configure, data, and utility folders. So here's where I can store different functions. So let's say I want to create a VI that will go in my action status section. And it also creates the .mnu files, which are actually what LabVIEW uses to populate your palettes in a certain way. So functions show up in your palettes. So it kind of manages that for you. And I can basically go to new. And rather than selecting VI, I'm going to select instrument driver VI. And I'm going to get another little wizard. So here I can either create from an instrument driver template, I can copy from an existing VI, or I can configure my own. So I'm going to show you from configuring your own. These ones are pretty easy. If you've configured your own, these ones are basically just copying and replacing certain elements of it. So very easy. You also can just add a blank VI and program it yourself as well. So now I can either select configuration VI or measurement VI. So a configuration VI is something where I'm just going to write data to the device. Now measurement VI is something where I'm going to write data to the device and then try to read data back. So that's basically the difference there. For this demo, I'm just going to do a measurement VI, but they're very much the same. There's just one little difference. So now I can include my command text here. And it could be whatever. So I could say add, and then I can use parameter names in parentheses. So I can say number 1 in parentheses and a space and number 2. So I've now added 2 inputs here. I can select each one and I can define its data type. So I'm going to set these both as real. And then basically down here you get a little preview of what the command will look like being sent over. I can click next. And now if I'm connected to the device, I can see my preview here. I can actually just select the device here and click run test. And this is going to let me know how many bytes were written and if there was an error and what data came back. So you can just test these as you're writing them. And it's basically writing the code for you. But basically, as you're defining these commands, you can test them if you have the device connected. And then, because we selected a measurement VI, it's going to return data. So now I can specify what that data type is. So let's say it's a number. I can also specify if this is an array of numbers and what the delimiter is there. And it's going to automatically include that. So for ours, let's just do a number. Then I can do the VI name. So let's do, add. I can specify the icon. So let's just call it add. Adds to numbers. And I can specify where it's going to be saved. Then I just click next and click finish. And it's going to generate my VI for me. So all of the Visa code is written for me. The VI is generated. It's documented. The icon's created. The connector pane. Everything's done. I can then open up this VI, and I can see here it's basically taking in those inputs. I don't know why it spaced everything so far out, but yeah, we're taking that number, formatting that into a string, taking that second number, formatting that to a string, doing a Visa write, and then doing a Visa read, reading the response and converting that to a float. And all that's handled for you. You didn't have to do anything. You didn't have to write any code. You were just using the wizard. And then you can basically go through, function by function and map each function this way. And then you have an instrument driver that anyone can install to their instrument driver section of their palettes and use in their projects. And it's easy to share, etc. So yeah, that's pretty much it for instrument drivers in LabVIEW. I hope that was helpful, and thank you guys for tuning in.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.